Good day, Dr. Eamon. We will now present about the result of our group project with a title of System of Linear Equations with subtopic of inverse matrix. This project involved with 3 persons, which is the first one, me, Lo Wei-jie, second one is Tony Tang, and the third one is William Ng. The first part is the history of mathematicians that involved in invention of system of linear equations. The first one is Brunel discussed. Second one is Gottfried Wilhelm Leibniz. Third one is the Carl Friedrich Gauss. And the last one is the Gabriel Cramer. The most important is the Gabriel Cramer, as he invented the Cramer's rule, which is an explicit formula for the solution of a system of linear equation. Cramer's rule is actually a basic of solving the system of linear equation by using the inverse matrix. So the concept of solving the system of linear equation by using inverse matrix, there are some conditions that the system must to obey. The first one, the total different variable in a system of linear equation must be the same with the total number of equations. If there are only 3 variables in the system, there must also be the 3 equations in the system. The second one is the power of each variable must be 0 or 1 only. The third one, the matrix form from the equations is not a singular matrix, means the determinants of the matrix form is not 0. So there are some steps involving in solving the system of linear equation by using inverse matrix. So here I will do an example with system of 3 linear equations and 3 variables. We will arrange the variables in sequence for each equation. Step 2, we will arrange the coefficient of variables into a square matrix. Then we will find the determinants and adjoint of the matrix. Fourth, we will calculate the inverse matrix of coefficient by using the determinants and adjoint. Fifth step and the sixth step is almost the same. We will arrange the variable and constant of the linear equation into a 3x1 matrix. Then we will arrange all the matrix in Ax equals to B form. A refers to the coefficient matrix, X refers to the variable matrix, and B is the constant matrix. Then last step is solving the problem by using the inverse matrix method. So there are total X steps involving in solving the system of linear equation by using the inverse matrix. The next part will be presented by Tony Tang.
Hi everyone, I'm Tony, metric number 284009. And here I would like to give some examples and solutions about how to solve the linear equations using the inverse matrix. Let's see the first examples. So the question gives us a matrix A and requires us to solve the following linear equation by using inverse matrix. So in order to find the inverse of matrix A, just like what we said before, the very first thing you need to do is find the determinant and the covector of matrix A. So how do we find the determinant of matrix A? You just need to sum out all the products of the elements of any one row with their respective covector, where covector is denoted by Cij equal to -1 power of I plus j mij. Let us move to the next examples. In this example number 2, we will find that the question gives us 2 matrices and requires us to find the inverse of both matrices if it exists, and lastly to solve the linear equations. So for this example, we just need to do the same thing like the previous example. First, we need to find the determinant and the covector of matrix A, using them to find the inverse of matrix A, and solving the linear equation by using multiplication between the inverse of matrix A and matrix X. A very special case in this example is that the inverse of matrix B does not exist. Since the determinant of matrix B is 0, it means that B is a singular matrix. A singular matrix is a matrix that does not have any inverse of matrix. As a result, matrix B does not have any inverse. For the last examples, you will find that the determinant of matrix A is -82. So you'll need to use the formula to find the inverse of matrix, which is 1 over determinant of matrix A multiplied with the matrix of adjoint.
Okay, my name is William Ng with matrix numbers 284613, and I'm going to present 4 application of matrix on our real life. And the first one, examples of our real life which related to the matrix that our mathematics in learning, which is cryptography. Cryptography is a science of information security, which cryptography includes of techniques such as music, words, and with image and other ways to hide all the information in storage and transit. Cryptography involves in encrypting data so that a third party cannot intercept and read the data, so that we can protect our data. For the first example of cryptography we can meet in our real life is video chipper that used to encrypt the video signal in early days of our satellite television. Okay, for the decryption process, they place the encrypted string of numbers that can be encrypted message into our matrix and multiply them to decoding the matrix number. For the instance of read message, that's read RAM, and the read RAM will be passed to the next person in the string of the numbers. Okay, we can see from here the cryptography works how here containing the data of numbers, equation of the matrix formula. So we're going to find the inverse of the increased matrix from here, and here we can use encrypted data to times of the matrix answer, and then we can get the streams of the signal. Then receiver then takes the matrix of the break apart into value offered each other those into a corresponding characters. Okay, the next one we're going to use our inverse metric in business. And like example here, Mr. X invested a part of his investment in 10% bond A and a part in 15% bond B. His interest income during the first year is 4,000 ringgit Malaysia, and if he invests 2%, 20% in 10% bond A and 10% more in 50% bond B, his income during the second year increased by 5,000 ringgit Malaysia. Find his initial investment and new investment in bond A and B using metric methods. So we let's see the initial investment will be X in 10% and bond A and 50% of bond B. So we have here all the two equations here, and we express the equation into matrix form like this: 8, 3, 8, 11, xy equals to our value of the income. So this also can be written in the form equals to x equals to b or x equals to a inverse b. So next one, okay, so since a determinant equals to minus 2 cannot be equals to 0, and because it's divided by 2, and here we can get the determinant times to the inverse matrix, so times, and here we can get the x equals to y, and the x equals to 10,000 and y equals to 20,000. So the new investment would be 12,000 and 22,000 respectively.
Thank you, doctor. That's all from us.